So we have problem here. The batteries shown in the circuit in figure below have negligibly small internal resistances. Find the current through the 30 ohm resistor, the 20 ohm resistor. The 30 ohm is this one, and the 20 ohm resistor is this one, and the 10 volt battery. So we have two batteries over here, 10 volt battery here, and 5 volt batteries at right hand side. So first of all, we have to determine how many number of loops are here. So to find the equation for particular loop by using Kirchhoff's loop rule, we can apply Kirchhoff's second rule, which is called loop rule. So I'm gonna go clockwise. So this will be my first loop, and the second loop is right here, loop number one, and the loop number two is this one. This is loop number two, and loop number three is this loop. I can say this is loop number three, loop number two, loop number one, loop number three. So I can go anti clockwise, but either way is fine. I will be getting same answer. That's why I'm going through this process. So let me write down the equation for this first step. Okay, first loop, I mean loop number one. So when you go from the negative to the positive of the battery, the EMF will be positive. So that's why I'm writing like 10.00 voltage as a positive, right? And going from here to here, this is the first resistance. So the direction of current, let me determine the direction of the current. Let me put it here, direction of the current. Let's say the current right here is I1, and the current passing through here is I2, right? So that current passing through here will be I1 plus I2. So from here, using Kirchhoff's rule in the first one, uh, 10 volt battery is positive, so positive 10.00 voltage. So I'm in the direction of the current, so direction of the current is going down through this section, 30 ohm resistance, and I'm also going in the same direction. That's why it will be negative, because there is a potential drop, right? So 30.0, which is the resistance, times a current I1. My symbol here is I1, so it's I1, right? So there are just two components in this electric circuit. One is battery, and other one is this resistance. Okay, so this is equal to 0. From here I can solve for I1, and I1 is equal to 10.00 divided by 30, which is 1 divided by 3, and this is electric current. That's why it will be in ampere. So once you divide this one, this will be 0 0.0 0.33 ampere. So this is the I1. So this is I1. So now let's calculate I2. So in this one we have this resistance, and this one. So let me write equation for this section. Let me just exactly copy just this section in another uh, and this was another resistance, right? So 20.00 ohm, 30.00 ohm, and here was a battery, right? And this one. So I'm going clockwise again. So this was the positive terminal, this is 50 volt battery, right? So writing equation for this part, current was I2, right? So I'm just copying from here. So I can write down equation like, so direction of the current is upward, and I'm also going in the same direction. That's why I can write like 30.00 times I2, right? So this is negative. So I'm in the direction of the current. So there is current potential drop. That's why. Oh, so it's down. Sorry, let me correct this one. So there was downward, right? I1 was going down. So that's why I'm in the opposite direction. So I1, so it should be positive, right? Positive. And then going through this one, the direction of the current I2 and my travel direction is same. That's why it should be negative. Negative 20 I2. So, and I have one battery here. I'm going from positive to the negative terminal, and the negative 5 equal to 0. Okay, so from there it will be, so putting value of I1, so which is from here 0.33 ampere, right? 30 times 0.33 minus 20 I2 minus 5 equal to 0. So calculating for I2, I will be getting, about putting into calculator, I will get 250 ampere. So this is the current passing through this section, right? So from here you can see this is current I2, which I get it from here 0.250. So, and the current passing through this one was 0.33. So what is the current right here? Current I passing through this 10 ohm resistance will be sum of I1 and I2. So current is I, this is port C, this was port B, and this was port A, right? And I will be I1 plus I2, which is 0.33 plus 0.250, which is the current passing through the 10 volt resistance uh, is 0.583